Well, we know that for a fact, right? Because you have different sizes of llama, you have different sizes of DeepSeek, and you have different sizes of GPT, right? Like the O1 has large, medium, and small. And the small one can perform fairly good, and it's better than GPT 2 and 3 and 3.5.
Hmm.
So clearly, the large GPT 3.5 with 500 billion or whatever size it is, we don't know since OpenAI didn't say.
Yeah.
But the small O1, the mini one, performs better than their old models that are bigger. So
Yeah.
clearly, I mean, that's direct proof that, yeah, you don't need 500 or 800 billion parameters because that's the new, smaller version performs better.
Right. Welcome to Practical AI, everybody. I'm Jeff. I'm here with Peter Lynn. Uh, Practical AI is sponsored by Pocket AI. Pocket AI is a tool you can use to edit the weights of your model. With Pocket AI, you can prune over 60% of the weights in your model and improve accuracy. Peter, we wanted to do a quick two-part, something boring and something interesting. Um, we wanted to end with some of the new video and sort of future movie capabilities inside of some of the new offerings in the AI space. Before we get to that, though, I want to talk a little bit just about model pruning.
Mhm.
Um, of course, Practical AI is a tool that does pruning, but there's other pruning methods and tools out there. Talk a little bit about the pruning space, how long people have been sort of interested in it, and what's happening, where's it headed, and how's it going?
The pruning kind of largely today works this way. And that is you train your model and you train it with way more layers and parameters than you need so that it gets good results. And then once you get to that point, what you do is you start to look at what you can remove without having a negative side effect. So that's a big issue right now is you can prune, but usually the accuracy goes down, and the error goes up. And in some cases, pruning causes it to catastrophically fail, meaning the thing that you train it to do, it just completely fails.
Okay. So the benefits of pruning are somewhat obvious, and that is with fewer weights, you should use less energy,
Yep.
compute power,
Less memory is the
less.
main thing.
Yeah. So why is this difficult? Like, why not prune everything all the time?
Well, the reason is that we can't understand what the parameters are doing, right? So this is that opaque problem that has been around since the beginning. And it goes back to so there's a paper or several papers about this term called catastrophic forgetting, where once you've trained a model, if you want to teach it a new thing, you have to take the new data, combine it with the old data that you used originally, and then just retrain it. If you only took the new data and you trained it, it would forget all the other stuff that it learned. And so it catastrophically forgets everything else that it learned.
Hmm.
Right. And so this is the problem with neural networks is we can't understand what the weights are doing. And therefore, what some people do is they'll look at the weights that are closest to zero and they'll prune it, they'll test it, and then they'll retrain. So this is what's called iterative magnitude pruning. So there's two ways you can look at it. You can look at the actual weights, or you can look at the activations, meaning you let's say you train a model for dogs and cats and elephants. When you feed it through, you look at what neurons fired, which parameters fired, and you go, okay, all the ones that fired, I'm not going to touch those. The ones that didn't fire, we're going to prune those. Well, the problem is you can prune it, but then you get side effects. And so a lot of research papers claim I've discovered a new way, but it's not really new, right? It's because it's all because the way the research world works is it has to be novel research. So if you say this is an improvement on existing method, you're not going to get your PhD. Right?
Yeah.
So you have to claim this is brand new, but
Yeah.
it's not really brand new.
Okay.
Yeah.
So just kind of setting things up again, you've got the data that's going to be used to train. You've
Yep.
got um, your framework for your model. Then you've
Yep.
got PyTorch or whatever. Then you've got your algorithm essentially, which defines the layers and
Yep.
smarter people than us have coded all those layers and what they do. And within each layer are all these th hundreds of thousands of parameters.
Yep.
And the art and science of AI is to get the right order, maybe build new types of layers. But what you're saying is that inside each of those layers, where all those parameters, those little math equations are happening, um, nobody knows what each of those are doing.
Yep.
And so this gets back to then the early stage of pruning was just removing layers from the algorithm, right? That was just the beginning, right? That was the
Right.
is that true?
Well, so some people did that, right? They said, well, if I've got 1 billion parameters, maybe I don't really. So the easy thing is you go, okay, I've got 1 billion parameters. You run your inference through and you look at where are the activations is in layer one, two, three, four. So let's say you've got 100 layers. You look at the layer with the least amount of activations and you just delete it and see what happens.
Yeah,
And you go, okay, cross my fingers, I'm going to delete a layer.
yeah,
And so usually something bad happens and then you retrain it.
got
You take
it.
the same data set and you just train it again for another X number of days, weeks, months, whatever it takes. And hopefully it recovers. Recover meaning it gets back to the original accuracy performance that you had.
Got it.
In many cases, when you trim layers or weights, you never get back to the original performance. And so this is a common thing that's been known for many years now.
For whatever reason, those those weights and those activations are important for something, and it's just because we don't know what they're doing.
Well, it's more important than that, right? It'd be like a neurosurgeon saying this one brain cell in your head is responsible for everything, which obviously isn't true. It's groups of neurons, but like when you do an actual activity, those neurons are participating in different things.
Yeah.
And so it's not just that it's like these four neurons, it's these four neurons for this particular thing you're doing. You do a different thing, it might be 8 different neurons, including those four.
Mm.
And so there's this complex math of like, okay, we've got all these parameters, they're all doing something, and we don't understand what the weights are doing. And therefore, today it's a brute force thing. You just go, well, the ones that are closest to zero, let's just trim those and let's see what happens.
Yeah.
And so people come up with clever techniques for figuring out like, okay, well, if it's next to other ones that are zeros or close to zero, we should prune those first versus ones that are close to ones that are like higher, right? So you just iteratively prune those values and then you test and you retrain. See, and this can go on for days or weeks or months. Like there have been cases and studies where people try to do iterative pruning and it works fine for one model, they go to another model and it just completely fails.
Okay. So, but the theory behind all of that is this idea that you can prune, that
Yeah.
there are too many parameters out there, that not all of them are doing anything, right?
Well, we know that for a fact, right? Because you have different sizes of llama, you have different sizes of DeepSeek, and you have different sizes of GPT, right? Like the O1 has large, medium, and small. And the small one can perform fairly good, and it's better than GPT 2 and 3 and 3.5.
Mm.
So clearly, the large GPT 3.5 with 500 billion or whatever size it is, we don't know since OpenAI didn't say.
Yeah.
But the small O1, the mini one, performs better than their old models that are bigger. So
Yeah.
clearly, I mean, that's direct proof that, yeah, you don't need 500 or 800 billion parameters because that's the new, smaller version performs better.
Right. Now, maybe the argument would be, well, we have better data, so that could be the other side of the equation. Um, but
Well,
still,
right, that's an excuse, right? I mean,
yeah,
yeah, the data, but the fact is the model is smaller is still better.
right, yeah, no, right. Well, and it's significantly smaller. We're talking,
Yeah, it's a head fake, right? It's like, well, no. It's like, no, it's a smaller data, smaller model, it does better.
right. Okay, so real quick then, Wanda and Sparse GPT, these are two of the either concepts or programs out there that are doing some pruning. How are they doing their pruning, and is it working?
So again, they claim to be new, but they're not. It's iterative improvement on existing methods.
Okay, and what are those methods? What are they doing? What are Wanda and
The same thing. They trim weights and then they retrain, and then they see what happens, and then they train. So if he gets back to the original level, they trim a little more, they prune a little more, and they train a little bit more. So you just go prune a little bit, retrain, prune a little bit, retrain.
why all the retraining? Why can't they just prune it and
Because they don't know what's important.
okay.
It's very simple.
And that's one of the big features of practical AI, right? Of a pocket AI, right?
Right. Yeah.
You don't have to retrain.
No, because we're looking at the weight changes over time. We're using a temporal analysis of the weights to figure out what's important. Yeah.
Okay. Good. All right. So quick pivot here. There's been a fair number of, there's so much noise on the image side, but even this week now we're getting noise on sort of the video side, right? So
Yeah.
we're seeing the video I saw of a person on one screen moving around and speaking and whatever. On the other, the split screen, they had decided to recreate everything instantly in Marilyn Monroe with her
Yep.
voice and everything.
Yep.
So it looks like her, everything. And the alarm was, oh my gosh, Hollywood's going to be out of business in, a couple of years. So what's happening in the movie side or the video side, and is it have we had some breakthroughs?
I wouldn't say they're breakthroughs. I would say it's this has been an ongoing progress. So behind this kind of take one photo or several photos and then animate it based on some of the human doing something, right? So that's a combination of pose estimation, where a model looks at a video and then figures out where the head is. And kind of there's actually a contest for pose estimation the last couple of years. And so that's one side of the model. The other side is taking an image and then building a 3D representation from that image and then using that to generate the video. Right. So it's taking all these different models, combining them together so you can take kind of mo real-time mocap and then apply it to a generated image.
So we're an iterative improvement we're seeing
Yeah.
right here,
Yeah.
and it doesn't strike as like breakthrough, but it is getting better, like
Oh
progressively.
yeah, I mean this has been in the works for at least 6, 7 years.
And
So
what's the how long until we can make an entire 2 hour movie using AI?
well, I mean depends on your writing. If you write a good story, then it actually doesn't matter if you're doing AI to do mocap and animation for part of it, right? Again, it comes down to the story. Like Hollywood wants to use Gen AI to write scripts, but as we mentioned before, Hollywood's been getting a flood of really terrible scripts that are generated.
Yeah.
And so now they're inundated with thousands and thousands of AI generated scripts that are just garbage.
But I would imagine that if someone tried to do that, like I've seen people do like they'll do like little fake TV commercials, right?
Yeah.
Using just mini clips of video that they generated on ChatGPT or something, right?
Yep.
And you can tell that it's this because the character, sometimes looks different. Sometimes they're wearing
Right.
completely different clothes. I mean, it's like, but they're stitching together these little tiny snippets of 3 and 5 second little videos, right?
Mhm.
So when will, let's assume they have a good script. When will Hollywood be able to make an entire movie?
I don't think Hollywood will be the one to do it, to be honest, because they're not on the cutting edge and they're mostly run by finance guys that have no clue about how to make a movie.
Okay, so let's say it's some kid in their
So
underwear.
it'll be some smart kid in
Yeah.
Brazil or Ireland
Yeah.
or Bulgaria or the Philippines or Malaysia or Africa somewhere. Some kids can be like, hey, it's only me and my buddy, but we have this cool story we want to make. And so then they'll write a script, they'll use these tools, and they'll make something that's good enough at at a super low cost, right? Like Hollywood to make a small movie now, like this, $10 million is considered like a nothing budget.
Yeah.
Like a small movie with no CG, no computer generated effects will run you in the 30 to 40 million range.
Well, but if I'm doing a 2 hour movie all in video, I've got a lot of processing time and power and memory and right.
Yep.
So I would imagine that it's not going to be it wouldn't be super cheap just to even Gen AI the video.
Right. Yeah. So like if you wanted to generate a full length movie that's 2 hours, that would be expensive for a small person. So here's the thing is, once open source gets good enough that you can run it on a MacBook, well, so now you can make a short 15-minute. And then you could then do something like James Joyce's The Araby, where you make 5 movies that are 15 minutes and then stitch it together as one big movie. So you can get really creative with like, okay, I want to tell a story about a town, but I'm going to capture it with 4 different characters, and each character will be 15 minutes. And then you have, something that's like 45 minutes.
So if we did it in 15-minute chunks, how long until someone can do that?
I don't know. Hopefully soon.
All right. Well, it's fun. It's fun to see all this innovation kind of hitting all at once, and the video side is certainly some good. We'll put a couple links in the discussion box, and of course, if you have questions, you can always ask. Peter, thanks for this. Remember, we are also on Spotify, so you can find us there. If you didn't already figure out the hack, always listen to our videos on 2 times speed, since Peter and I talk really slow. We'll catch you next time. Thanks, everybody.